Okay, I wanted to run through this X-ray circuit interactive. So if we start here, it'll take us to the outlet. And what we get from the outlet is 220 to 240 volts of electricity. We're also getting 15 to 20 amps. Remember, volts is our pressure, kind of like water pressure. Amps are kind of describing our electrons that we're using. You could think of this as the water. So here's your water pressure, and here's your water. You can think of hertz or your frequency here is how fast that water is moving. And then remember, through this outlet, we get alternating current. So it looks like this. This is the sine wave, the waves that we have been seeing for electromagnetic energy. Whenever we get a wave here, a moving electric field or a moving current, we're also getting an associated magnetic field. And this is also because it's fluctuating. It's fluctuating from positive to negative. We have alternating currents. You could think of this almost like if you get a battery between your fingers and you start flipping it back and forth so the negative and positive ends keep switching. It's kind of like that, like you're moving a battery, you're twisting it in your fingers. So the positives and negatives keep switching sides. If we go back here and click on this red flashing button now, what we're going to get is information on the auto transformer. The auto transformer could be called a variable KVP selector. It's what's going to set the pace for the rest of your KVP. It has a line compensator attached to it because through an outlet, yes, we get 220, 240 volts, but it's not perfect. And most electrical devices account for this, including the X-ray circuit. So a line compensator is attached here to make sure that our X-ray circuits always are using an exact amount of energy. Excuse me. It uses self-induction, and I gave us those flux lines we've been talking about here to show you. All self-induction means is that you only need one coil of wire to get your flux line and induce a current to keep flowing. Now, in our X-ray circuit, this auto transformer, and I want to emphasize this, will supply energy to both the anode side, which includes these circuits up on this side, up on the top here, and the cathode side, which is through the filament circuit here at the same time. All of these things that we see here are happening at the same time. And on that note, they're all happening when you prep the rotor. So when you get that exposure button, you press it halfway down. What you're doing is you're running electricity through all these different components and setting up your potential here in the X-ray tube. All right, if we were to click on the KVP meter, what we're going to see is information on it. It's here before the KVP is stepped up from the 240 volts we get from the outlet to the thousands of volts that we need for our X-ray exposure. So before that happens, it monitors it. And if things aren't going correctly with the voltage being applied to the system, that meter helps tell the system, hey, things aren't quite right. We got to stop the X-ray exposure. All right, so remember, all of these parts, the filament circuit and these circuits up here are happening at the same time. But I'm going to go ahead and continue with just this side for now. So if we move along, the exposure timer is kind of like your AEC. It's how much time you want to expose for. And AEC kind of takes over that and decides for us using the detectors. So instead, I'm going to skip to the step up transformer. And if we were to click on that red button, if you click on this red button, it'll take you here. Now the primary side, which is this orange, this first side over here, of the step up transformer induces a current with those flux lines that we've been seeing. I didn't put them on here, but imagine those flux lines again. So this primary side will induce a current in the secondary side over here, or indicated by the blue over here, that takes the voltage to kilovolts. So we're moving from voltage to kilovolts. Mutual induction is used, so those flux lines radiate out from this side, and because there are so many more coils of wire on this side, the voltage gets bumped up by a great deal without these two coils even touching. It's all due to the flux lines. And the flux lines produced here, because of the flux lines from this coil moving over and inducing that current, will be greatly increased. So I gave you kind of a slower moving line here to a greatly increased line here, or sine wave, I'm sorry. And I put a voltage on her shirt to show you that the voltage is stepped up or increased. And that's going to increase the amount of potential we have and the amount of force applied. And remember, voltage is kind of like our water pressure or force. All right, so if you were to click on that dot right there, you're going to be taken to the rectifiers. Now, the rectifiers here in the system, I zoomed in on one of these circuit element drawings there. And what this means is that at certain times, think about that battery again, right? You have it between your thumb and your forefinger, and then you start twisting your wrist so that the battery is like flipping over. We don't want that to happen anymore as we get closer to the 2. We needed it for the transformers. We have to have it to have created those flux lines for the step-up transformer. But now we don't need it anymore. We actually need direct current. So what these little rectifiers do is stop the battery, basically, right? The positives and negatives, think about it, stop them from flipping. And when it gets to that negative side here, every time it wants to switch over to this side, it stops it. But it still allows it up here on the positive side. So what the wave would end up looking like is nothing's happening down here. Everything is kept in the top. And in fact, because of the arrangement of the rectifiers, what you usually get is the wave down here, instead of it being wasted and just disappearing, which we know can't happen, it's usually flipped up and put on this side. Regardless, when it's rectified, you have no more alternating current. You're not flipping that battery back and forth anymore. It's just still. It's just direct current up here on this side of the line. All right, so if you were to come back here and find, well, let's click on this one first. And we'll see that there's a little connection there in the circuit. That little connection between the secondary and filament circuits allows the secondary circuit to provide a charge specifically for the focusing cup. And that's the only part of the cathode that the secondary circuit plays a part in. So the focusing cup, just this ring, around the filaments, is supplied with a negative charge by the secondary circuit. I've seen that as a registry review question in addition to other things we're talking about. So I wanted to make sure and make that clear. Meanwhile, these filaments here, these little coils here, are supplied by the filament circuit, which we'll talk about in a moment. So again, when you take a look at this circuit, you'll notice a little attachment between this side and this side, right? And that's what that's about. Finally, if we click on the anode there in the X-ray tube, we're going to be taken to, you'll be taken here. And what we see here is the rectifiers have made sure that this is just going to be direct current, no more fluctuating back and forth. It's direct now. It's all up here in the positive area of this line, this kind of graph. And what happens is we get that consistently positive charge on the anode. That's going to give us that potential between the two electrodes. With that positive charge placed here, just consistently, and the negative charge that we'll talk about here in a moment placed here, we have our potential. So that's how we got to the anode. Now, if we go back and let's see what's happening in the meantime with the filament circuit, which is this here, kind of a pinkish purple color. So if you click on that red dot, you're going to be taken to the rheostat. And so if you click on it, you'll be taken here. The rheostat is a variable resistor. And here is our water analogy. If you kink the hose, right, you might still get a little water coming out, a little amperage coming out, but it's greatly reduced. And what that does is builds up a lot of pressure and heat, because we know right from the X-ray system, it's actually still, even to this day, kind of an inefficient process. So much heat is produced, and 1% of that will be our X-rays. So that's kind of where we start to get our heat there, that rheostat or resistor. And we need heat, right? Because we need to boil electrons off at the filament with thermionic emission. So if we come back and we start, after that, we start talking about the step-up transformer. Click that red dot and you are going to be taken to step-down transformer. You'll be taken to this page. So I show my person here. You'll see voltage. Voltage is now going down. And as voltage goes down, amperage goes up, is increased. So we go from A to MA. And remember, that's what you're setting when you set things on your control console. Just like here on this one, when you're setting KVP on the console, this is what you're kind of adjusting. So anyway, if we go back to MA here, you'll see that there are more coils on this side than this side. And here we see it in the circuit as well, which means the flux lines coming out of these coils will be greatly reduced on this side. All right, if we go back here, and if you're using this interactive and you click on this dot, what you're going to see is, I forgot to show you one more thing, but we'll go back to that in a second, is the cathode. So you'll see the cathode has a negative charge. The filament circuit is supplying boiled off electrons, which create an immense negative charge at the cathode. So when a KVP force is applied through the system, the potential difference between the negative and the positive causes electrons to cross the vacuum and create our X-rays. Now, one thing I forgot to mention. Okay, so if we go, where was it? It was here. So when you get to this page, notice how this red dot is pulsing too. If you click on that, and these aren't working in my presentation mode, but it should work for you. If you click on that red dot, you'll get this screen. I know this has a lot of stuff on it, but I'm going to walk you through it real fast. So here we have our wave, right? Okay, we made sure nothing's going in the negative direction here. We're not alternating anymore, so we're going to get that consistent positive charge on our anode, right? Well, if you use older systems that pump in a single wave of electricity at one time in the circuit, you have single wave generation. That means you get a rectified wave with 100% ripple. Now, all that means is you could get anywhere between no KVP to 100% of the KVP you set. So let's say 70 or 70,000 volts, right? Of force moving through your X-ray system. What that means is while you're pressing the button down, you're pressing it down, right? You're doing your exposure. For 1 split second, you get 70 kVp of force moving through your circuit. And then in the next split second, you get nothing going on. No X-rays are produced. Then when it starts to go back up, you start to get X-rays up to this force and then back down. Not very good system. I don't think anything still uses a system like this. 3-wave, maybe some systems still use it. So waves are 3 waves at a time, and even with more pulses, depends on the system, you'll get within 4 to 13%. I need to double check these, but basically what that means is you'll get anywhere between 87%, which is, you do 100 minus 13, you'll get 87, right? To 100% of the KVP. So say you set KVP, 70 KVP. When you're pressing your button down and doing your exposure, for a split second, you might be only getting 61 volts of force moving through your system, whereas the next split second, you'll get 70. But you'll still at least get a consistent amount of X-rays being produced while you're exposing. These are what we mostly use. You'll find these pretty much everywhere now, like in our X-ray lab. The high frequency generator is a massive amount, the frequency is so fast that what you'll end up getting once it goes through those rectifiers, right, is pretty much the KVP you set. Whatever you set, that's what's moving through and forcing through the system as you go. All right. If on this screen, if you get there, you press this dot, it'll just take you to this screen here. So I hope that helps with the X-ray system and try and explore this for yourself as well.